Betelgeuse, the enormous red supergiant closest to Earth, has shown a remarkable decline in brightness in recent years, sparking a wide range of reactions worldwide. Some theories suggest this fading might signal the approach of a supernova, a catastrophic explosion that raises concern among scientists and the general public alike. Betelgeuse, a major star in the Orion constellation, has regained some of its former brilliance after dimming, yet it seems to be entering a phase of reduced activity. Experts are now pondering the future of Betelgeuse and whether its eventual detonation could have any impact on Earth. 33 seconds Orion, one of the most iconic constellations in the sky, is well known for its two primary stars, Rigel and Betelgeuse. The latter, also referred to as Alpha Orionis, is the largest and most luminous star in Orion. Observations made by NASA's Hubble Space Telescope and various other observatories revealed that Betelgeuse underwent an extraordinary mass ejection in 2019, an occurrence never before recorded in any star of its kind. Although coronal mass ejections, CMEs, are relatively common with our Sun, this particular outburst from Betelgeuse is unique and has generated significant intrigue among astronomers. This massive burst of mass expelled by the star was 400 billion times greater than the typical CME observed in stars like ours, briefly obscuring some of its light and leading to its unusual dimming. Estimates regarding the distance of Betelgeuse from Earth vary, with some placing it as far as 724 light-years away. Measuring the distance to red supergiants such as Betelgeuse is challenging due to their vast size and unusual traits. 1 minute and 38 seconds Betelgeuse is one of the most luminous stars visible from Earth, shining with about 100,000 times the brightness of our Sun. However, such intense luminosity comes at a cost. Betelgeuse is expending its energy rapidly, burning through its fuel and speeding up its inevitable demise. The star will eventually exhaust its fuel supply, collapsing under its own gravity and potentially triggering a supernova, a violent explosion that might eventually leave behind either a neutron star or a black hole, assuming current scientific theories hold. Does Betelgeuse pose a danger to Earth? If the star were to explode in a supernova, its outburst could have catastrophic consequences. Supernovae are capable of emitting light so bright that it can rival an entire galaxy. Even if Betelgeuse is relatively distant, such an explosion would be hard to ignore. Since the last supernova observed in our galaxy was in 1604, and the most recent one in 1987 occurred in the Large Magellanic Cloud, 169,000 light-years away, the destructive potential of a nearby supernova remains an intriguing yet concerning possibility. If such an event were to unfold within our galaxy, it could have profound implications for Earth. 2 minutes and 43 seconds supernovae, though spectacular, are much less powerful than gamma-ray bursts, which are on an entirely different scale. While supernovae have the potential to obliterate biospheres and blanket planets in deadly radiation, their ability to strip away a planet's ozone layer is particularly troubling. A weakened or destroyed ozone layer exposes the planet to harmful ultraviolet radiation, which could result in an extinction event. The initial radiation burst from a supernova is dangerous, but the more insidious threat comes in the form of cosmic rays that arrive hundreds of thousands of years later, capable of further damaging the planet's surface and potentially preventing life from recovering. Historical records show evidence of past supernovae. For example, traces of iron-60, a radioactive isotope formed during supernova explosions, have been detected in Earth's oceans and lunar regolith, suggesting that Earth may have been affected by supernovae within the past few million years. Although astronomers have ruled out any imminent supernova threats, they have discovered another potential risk. Certain types of supernovae emit radiation that can travel vast distances and inflict damage on planets like Earth. When a star nearing the end of its life is surrounded by a substantial amount of material, a specific type of supernova may occur. 4 minutes and 17 seconds, the shock wave from the initial explosion strikes the surrounding disk, triggering the emission of vast amounts of X-ray radiation. This high-energy radiation has the potential to deplete a planet's ozone layer by as much as 50%, which could induce an extinction event within a range of 150 light-years. Fortunately, no such X-ray supernovae are currently known to be near enough to Earth to pose a direct threat. These findings have caused astronomers to reconsider the boundaries of the galactic habitable zone, the region within galaxies where life is likely to exist. Star formation in the outer regions of a galaxy is too low to create the necessary elements for rocky planets, while the inner regions, where stars are born and die quickly, are hazardous due to frequent supernovae irradiating the surrounding areas. This research suggests that the inner boundary of the galactic habitable zone may be farther from the galactic center than previously thought. 5 minutes and 17 seconds. So, How would Betelgeuse's supernova appear from Earth? While the biosphere on Earth would likely remain intact, the spectacle would certainly be impossible to miss. According to astronomers Goldberg and Bohr, Betelgeuse's explosion would result in a luminosity roughly half that of the full moon, visible for several months. This brightness would be visible even during the daytime and cast shadows during the night. For several years after the explosion, the supernova's remnants would continue to be visible to the naked eye. Although Betelgeuse's supernova would be a fascinating event, it would not be without consequences. The global fascination with such a phenomenon would be undeniable, but the long-term implications for Earth's environment remain uncertain. As scientists continue to monitor this red supergiant, we can only wait and watch, hoping that the threat, if any, is far off. The outcome of Betelgeuse's eventual supernova explosion would be a stunning sight, but not without significant consequences. The enormous burst of light from such an event would likely be the second brightest object in our sky, right after the sun. During its peak, it would shine with an intensity so great that it could easily outshine the moon, making it visible during daylight hours and casting visible shadows at night. Despite its brilliance, it's important to note that visible light emitted by a supernova accounts for only a small fraction of the total energy produced. The more pressing concern is the high-energy radiation released, typically in the form of gamma rays and X-rays. These forms of radiation are extremely dangerous and have the potential to strip Earth's ozone layer, which protects life from harmful ultraviolet radiation. Without this layer, life on Earth would be exposed to dangerous levels of radiation, increasing the risk of a mass extinction event. The aftermath of the explosion would not end with the immediate burst of energy. Cosmic rays, subatomic particles accelerated to nearly the speed of light, would follow, continuing the devastation by bombarding the planet for hundreds of thousands of years. These particles have the power to penetrate Earth's atmosphere, further degrading the ozone layer and potentially altering the course of life on the planet for millions of years. The effects of such an event would be long-lasting, preventing ecosystems from recovering and possibly stalling the re-establishment of life on Earth. Although astronomers currently do not see any supernovae within a threatening distance from Earth, the detection of iron-60 raises concerns about the potential hazards of a nearby star's explosion. These findings highlight the need to closely monitor the stars within our galaxy, particularly those in the late stages of their life cycles, such as Betelgeuse. The aftermath of the supernova. 13 minutes and 33 seconds. The moment of Betelgeuse's explosion would be unlike anything seen in modern history. For weeks, astronomers and casual observers alike would witness the dazzling celestial spectacle, a luminous event so bright it would outshine even Venus in the night sky. Scientists would rush to analyze the event, measuring its energy output, tracking its shock waves, and attempting to predict how the supernova's debris cloud might evolve over time. As the brilliant light fades over the months and years following the explosion, the remnants of Betelgeuse, once one of the most iconic stars in the Orion constellation, would become a growing nebula, slowly expanding into space. This cloud of dust and gas, enriched with heavy elements forged in the explosion, would be a sight of awe and wonder. It would eventually disperse, potentially forming the raw materials for future stars and planets, just as past supernovae helped shape our own solar system billions of years ago. 14 minutes and 10 seconds back on Earth, scientists would continue studying the impact of the explosion. While the initial radiation burst would likely have little immediate effect on our planet due to its distance, long-term monitoring of cosmic ray levels and potential ozone depletion would be crucial. Satellites and observatories would scan the skies for any unusual changes in radiation, ensuring that Earth remains safe from any lingering effects. However, the loss of Betelgeuse would change the night sky forever. The once recognizable Orion constellation would now be missing one of its brightest stars, leaving a cosmic void where it once shined. Future generations would look at Orion's shoulder and see only the remnants of what was once a mighty red supergiant. The birth of a neutron star or black hole. 15 minutes and 2 seconds. What happens next would depend on the final mass of Betelgeuse's core after the explosion. If its core is below the critical mass threshold, the supernova would leave behind a neutron star, a dense, rapidly spinning remnant no larger than a city but containing more mass than the Sun. This neutron star could emit powerful beams of radiation, making it detectable as a pulsar from Earth. On the other hand, if Betelgeuse's core were massive enough, it would collapse further into a black hole. This invisible remnant would lurk in Orion, warping spacetime and slowly consuming any nearby matter. Although distant enough to pose no threat to Earth, its presence would mark a significant moment in astronomical history. the closest black hole ever directly linked to a visible supernova. 15 minutes and 50 seconds, the formation of a black hole or neutron star would open new avenues for scientific discovery. Astronomers would use high-energy telescopes to study the aftermath, looking for gamma-ray bursts, gravitational waves, and other exotic phenomena associated with stellar collapse. It would be a rare opportunity to observe the life cycle of a massive star in real time, providing valuable insights into the fate of other red supergiants in the universe. A new era of exploration. 16 minutes and 30 seconds. As the years pass, the shockwave from Betelgeuse's explosion would continue traveling outward, carrying with it elements like carbon, oxygen, and iron, the very building blocks of life. In a distant future, the debris cloud could contribute to the formation of new stars and planetary systems. Perhaps billions. A universe in motion. 17 minutes. In the years following Betelgeuse's supernova, the night sky would never be the same. Where once the fiery red giant burned, now only a faint nebula remained, an expanding cloud of stellar debris drifting through the cosmos. Observatories across Earth and in space would continue to track its evolution, capturing stunning images of the remnants glowing with the energy of ionized gas. For astronomers, this would be the discovery of a lifetime. The explosion's aftereffects would allow them to study how supernova remnants interact with interstellar space in real time. Scientists would analyze the high-energy particles and radiation emitted from the core collapse, looking for signs of a neutron star or black hole. If a pulsar emerged, a rapidly spinning neutron star sending out rhythmic bursts of radiation, it would be one of the most fascinating celestial objects ever observed. Meanwhile, in the farthest reaches of space, the shockwave from Betelgeuse's demise would continue its journey, potentially disturbing gas clouds that might one day collapse to form new stars and planets. The cycle of cosmic birth and death would persist, as it had for billions of years before. The effect on Earth. 18 minutes and 12 seconds. While the explosion itself posed no direct threat to Earth, astronomers remained cautious. Cosmic rays from the supernova could take years, even centuries, to reach our planet. High-altitude satellites would monitor any increases in radiation, though Earth's magnetic field and atmosphere were expected to shield most of the harmful effects. However, there was another lingering question. Had similar supernovae in the past subtly influenced life on Earth? Some researchers speculated that past extinctions might have been triggered by distant stellar explosions. The discovery of iron-60 isotopes in deep-sea sediments, evidence of previous supernova fallout, suggested that our planet had already experienced the echoes of stellar deaths before. Would Betelgeuse leave a similar mark in Earth's geological history millions of years from now? A legacy among the stars. 19 minutes and 5 seconds. As the world marveled at the fading brilliance of Betelgeuse's supernova, astronomers turned their attention to other red supergiants. Would Antares, the heart of the Scorpius constellation, be next? What about other aging giants in the Milky Way? The event would serve as a catalyst for renewed efforts to study stellar evolution, helping to refine our predictions of which stars might go supernova within our lifetime. For centuries, Betelgeuse had inspired myth, legend, and scientific curiosity. Its explosion would become a defining moment in astronomical history, a celestial spectacle that united people across the globe in wonder. From professional observatories to backyard telescopes, millions had witnessed the transformation of a dying star, a cosmic finale billions of years in the making. But as one star's light faded, new ones would take its place. Somewhere in the depths of space, the elements forged in Betelgeuse's explosion would one day seed new worlds, continuing the endless dance of creation and destruction that defines our universe.